a couple of people already that this morning someone pointed me to a web page where I was on the same page as Lady Gaga. We arrived. When I question this thing on there, it doesn't happen just with a single person like a lot of people. I had the pleasure to work with a lot of people. Many people share this honor. Also, one thing that's been valuable at NIST here is that myself and other colleagues, we have good support from our managers. Now, my boss, Tom O'Brien, but his boss, Catherine Gilligan, many other people throughout the years. So I think it's also a credit to them that they provide an environment where we pursue this kind of work. As I say, I'm just one person in this mix, and a lot of people credit for it.
Let's take some questions. What we'd like to do is alternate between questions from members of the press who are in the room here in Boulder, and then folks who are on the telephone line. So let's start inside here. Any questions or comments for Dr. Wineland?
I guess in plain people terms as possible, can you describe the work that got you this prize?
Well, okay, so I think that, actually I've forgotten exactly how the citation reads, but our group does experiments with single atoms, in our case, charged atoms, and what we've been able to progressively do, we and other groups throughout the world. Over the years, we've basically been able to control their quantum properties with increasing precision. So Tom mentioned that this has applications in atomic clocks. So using these techniques, we've progressively been able to make more and more accurate atomic clocks. Something that's happened in the last 15 years or so is that we've been able to also apply these control techniques to start to play games where these quantum properties might be used in a computer, so-called quantum computers. And I would have to say, at this point, I wouldn't recommend anybody buy stock in a quantum computing company. But I think we're optimistic that as the technology improves over the years, that this quantum computer really will bring unique capabilities. And I think that actually one of the reasons that the interest started in about 1995 was that a computer theorist, Peter Shor, came up with an algorithm that showed that if you could make this quantum computer, you could efficiently factorize large numbers. If you have a large number and it's the product of two smaller numbers, you can find those two smaller numbers. And this sounds a little bit esoteric, but in fact, the security of almost all encryption systems that we use derives its security from the inability to factorize very large numbers, hundreds of digits. And this quantum computer, if we could make it, could actually solve that kind of problem. Now, in fact, this problem, as I say, was a big impetus to get the field going, but it's probably the hardest problem people have thought of. Quantum computer might come into place. So I think one of those physicists and other scientists feel where the nearer term application for such a device is to solve problems, physical problems that can be mapped onto this quantum computer, but problems that are intractable on an ordinary classical computer, the kind of machines we can have now. And although we haven't really reached the turning point where we've been able to do problems that haven't been simulatable on a classical computer. I would say, I think maybe in the next decade or so, we'll cross that threshold where we can do problems that are intractable on a classical computer. So this is maybe still ways out, but I think as scientists we're optimistic about the future.
Do we have a question from our participants on the telephone?
At this time, if you would like to ask a question, please press star and then 1 on your touch-tone phone. Record your name. To get to the question, please press star 1 now. 1 moment, please.
While we're waiting for them to record their message, is there another question from inside the house here?
You ever dream of winning this award? Oh, sure. Sure, even as a kid, you know, this is kind of the biggest thing, and sure you think about it. I think, you know, one thing to say is that there's many other people that could have gotten this work besides me, because there's a huge number of people working on this very closely related problem. Yeah, I mean, I think, you know, you learn that there's a possibility, but as I say, there's so many people that have gotten this award besides me that you don't want to bank anything on anything like that. So I must say this, you know, I hadn't heard of possibility before in the past, but this year I hadn't honestly heard any rumblings, so I thought, well, maybe my time has passed. So it really was a surprise.
Are we ready for a telephone question yet?
We do have a question from the phone lines. We have a question from Bill Lindelof. Your line is open, and please state your affiliation.
Hi, this is Bill Lindelof. I'm a reporter with the Sacramento Bee newspaper in Sacramento, California. My question is, from what I read, you grew up here in Sacramento, is that right?
That's right.
And graduated from Encina High School in '61?
That's right.
I wondered, I'm taking into the Wayback Machine, talk about clocks here. Did your interest in science and math, was it nurtured at Encina?
I would say so, actually. I took I don't think I was the best student when I was in high school, but I must say when I took, there was a physics class I took in my senior year, and I thought, well, this was pretty cool. So, in fact, I started as a mathematics major in college, but I not very long after I switched my major to physics. And I must say that this high school class in physics really got me interested. Here I am.
Different kind of high school now. It's more ethnically diverse, and the neighborhood's a little different. But what message would you have for the students at Encina today?
Well, just find something you like and keep going. And, you know, in my case, I guess, you know, I was pretty straight arrow in the sense that I got onto physics pretty early, and I still like it. But it doesn't mean that you can't switch your interest and still be successful. But I think it's, you know, it's important to take an interest in something and then just go for it. It takes a lot of hard work, but I think that's, you know, that's a way to success.
Thanks very much.
Thank you. Are there any questions inside the house? Yes, sir.
Describe your relationship with the other literature.
Yeah. So actually I've known Soch Roche for, I don't know,